This video will include the Unit 8 review questions to study and prepare for Test 3. Let's look at question number 4. At a certain time of day, a tree has a shadow 50 feet long. At the same time, a 6-foot tall man stands next to the tree. His shadow is 20 feet long. What is the height of the tree in feet? So let's first draw a picture. So we have our tree and its shadow. So this would be the tree and its shadow. Let's go ahead and connect it to make a triangle. At the same time, we have our 6-foot man and his shadow. So we have our shadow of 50 feet long off the tree. At the 6-foot tall man, we have a 20-foot shadow. So of course it's always good to reread that problem and make sure that you've set up your pictures according to the information that's been given. With the situation with the shadows, that makes similar triangles. So we can solve the height of the tree. We'll just let it equal t or x, whatever variable you would like. We'll let that be a variable and we will set up a proportion. Similar triangles have proportional sides. So our tree, come over here and correspond to the height of the man, equals, return to your picture of the tree, we have the length of the shadow, and then get the corresponding length of the man's shadow. So once you set up your proportion, you cross multiply to solve. So we have 20t equals 6 times 50 should give us 300. And then solve for t by dividing by 20. So that 300 divided by 20 gives us 15. So the height of the tree is going to be 15 feet. Let's look at problem number 5. The diagram shows the side lengths of two similar triangles. What is the value of x in kilometers? So here is our x. Again, similar triangles, and it told you that we have similar triangles. Similar triangles, the sides are proportional. So let's set up the x to its corresponding piece. So this x is going to correspond to the 8 equals, it does not matter the number you pick from this triangle. You could use the 15 or the 35. I'm going to stick with the smaller number. So 15, if you choose the 15, it does matter which one you pick in the other triangle. It has to be the corresponding side. So 15 goes with the 3. If you would have chosen the 35, it would correspond to 7. So make sure the corresponding side lengths, you set that up in your proportion. So we cross multiply to solve. 3x and then 8 times 15 gives us 120. Divide that by 3. We get x equals 40. 120 divided by 3 gives us 40. And of course our units for this problem are kilometers. Let's look at problem number 7. The two triangles shown are similar. Which angle has the same measure as RQS? So we first have to be careful that Q in the center, we're going from R to Q to S. So it's talking about this angle. Let's actually highlight it. R to Q to S. So it's talking about that angle there. So which which angle is going to have the same measure of RQS? RQS, because the Q is in the center, we're talking about that angle there. Well, we have previously seen in the two previous problems that corresponding sides are proportional, but also we need to know for similar triangles that the angles, corresponding angles, are congruent. So this angle Q corresponds to angle U. So those would be the congruent measures. This angle RQS is going to be congruent to this angle U. So let's use the three-letter naming. Because we start at R, we'll need to start at the T, since that's the 90-degree angle. We'll need to start here at the 90-degree angle. So we see that T to U to S, this will be the congruent angle. They have the same measure, so we will choose option D there. Corresponding sides are proportional, corresponding angles are congruent. So we needed to know here corresponding angles would have the same measure, they would be congruent. Question number 8. We're going to use the similarity rules to determine if the triangles are similar, and then we will write our similarity statement. The different options for similarity rules, we can use angle, angle, side, angle, side, or side, side, side. Those are our options for our similarity rules. So let's look at this first pair of triangles to determine if they are similar. Well, we first obviously see angle A, that 65-degree angle, corresponds to angle D. Because they're the same measure, they are congruent. So angle A is congruent to angle D. So far it looks like we might be able to prove it with angle, angle, or side, angle, side. We would not try to choose side, 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 because we have a pair of congruent angles. You would have to have corresponding sides. So that is not an option that I will continue to try here. I definitely have a pair of angles. So let's try angle, angle. Since I'm given another angle, I actually have no sides given in these diagrams. So side, angle, side would not even make sense for trying to prove these triangles. Angle, angle, I would need another pair. So this 48 would need to pair up with another angle. However, I see the 67. I don't know this other angle, but I could find angle E. Angle E is going to equal 180 minus your angle D, which is 65, and minus this angle F, which is 67. So we can take and find that angle measure. So 180 minus 65 minus 67 gives us a 48-degree angle. So we find out that it actually does correspond, they are congruent to angle B. So this, we'll mark it with 2 markings just as we did there with angle B. And we can say that for a second pair of angles, because we need angle, angle, so that was our first pair. And now for our second pair of angles, we'll say that angle B is congruent to angle E. And it's enough to stop there. You don't have to prove all 3 angles are congruent, because once you have 2 pair of angles that are congruent, the third one, just by the nature of a triangle, will be congruent. So it's enough to stop with just angle, angle. So we used our similarity rules to determine if they were similar. So we do now know that they are similar, so we need to write our similarity statement. So in order to do that, we will name the first triangle. It does not matter how you name it. You can call it triangle, so use the triangle symbol, A, B, C, do them in alphabetical order. You can try to spell a word, so C-A-B, you can do B-A-C. It does not matter the order that you name the first one. So I'm going to go with C-A-B. I like to try and spell words. Because we're writing our similarity statement, we're going to say triangle CAB is similar to, so it's just the squiggly line. Remember, the equals with the squiggly is congruent. This means similar. So triangle CAB is similar to triangle C. We never actually found out, but C would have correspond to F. So that's how we have to write it in our similarity statement. Then we go with our next angle. So we have angle A. It corresponds, here in our picture, angle A, we found that it corresponds to angle D. And then finally, angle B, we found that it corresponds to angle E. So triangle CAB is similar to FDE by angle. So that is our similarity statement. Let's look at our next example. When we first look at our image, we see some side lengths, and it's also important to notice the angles. These are vertical angles, and so that does mean that they are congruent. We do not know anything about the other angles that are here in the picture. We also don't know anything about the other sides that are not labeled. We can only use things that we are known and given as far as our proof. So going back up to our options, angle, we don't have enough information for that. We only have one pair of angles. We would need two pairs. Side angle side is actually what we will use in order to prove this pair of triangles are similar. We've got a side angle and side, and we hope to correspond with the side angle and side in the other image. Notice we cannot use side, side because we don't have all three sides. So let's take a look at our side lengths. We definitely know our angle. So if we're going to try to do side, angle, side, we've already mentioned our angle. So angle, let's use the three-letter naming. So BCA is congruent to angle because we started at B and it goes down the shorter side. We need to look at our numbers. The shorter side would be starting at D, C to E. So that's our angle. Let's look at our sides. Our first pair of sides, let's use the BC side. So that's 3.5. And because that is the shorter value of the two values that are given on that triangle, it's the shorter side. It should correspond to the shorter side in the other triangle. So 5.6. Let's reduce that to a fraction that makes sense without those decimals. So we want 3.5 and 5.6. You can set them up in alpha y equals or just divide them. If you divide, hit math, fraction, and it reduces to 5/8. So our goal is to also see the next pair of sides to be proportional, so equaling to 5/8. So let's take a look. We want to do the 4.0, or just 4, because it's the longer side in this triangle. We're going to compare it with the longer side in the other triangle. So again, let's reduce to a fraction that makes sense. So 4.0 with 6.4, math, fraction, and looky there, it is 5/8. So we proved with side angle sides, our sides were proportional, meaning those ratios are equal, and our angles are congruent. So this is a pair of similar triangles. So let's name our similarity statement. So first, we want to name triangle, however you want to call the first triangle, whatever three letters you see. You can do in alphabetical order or try and spell a word. So let's do this one just ABC this time in alphabetical order. So triangle ABC is similar to, if A corresponds here to E, it has to be in that order when we name our triangle. A, remember it was down the long side of the triangle, so that's why we're going to pair it up with E because it's down this long side of the triangle. So A, we went to B, so we travel up the side with no value, so we're going to travel to the D on that triangle, and then finally C. The triangle ABC, A to B to C, has to correspond in your name. It's similar to E to D to C, so the letters have to correspond even in the naming. So those were similar by side, angle, side. Let's look now at question number 11. We're going to determine if the following dilation will result in an enlargement or reduction. So when you do dilations, it results in similar figures. So if we took our ordered pair and multiplied it by 3/4, we should be able to determine if it's an enlargement or a reduction. So let's first talk about, in order to be an enlargement, the K value must be greater than 1. So when you're multiplying by a value, and that K value, that scale factor is what this is called, scale factor is greater than 1, it would enlarge the image, making a similar figure. In order to be a reduction, the K value has to be between 0 and 1. So most often we think about fractions or decimals. Where you have to be cautious is if your fraction is an improper fraction, it actually falls in this category of being an enlargement. So think about if it's between 0 and 1, then that would make it a reduction. Don't just assume fractions and decimals make a reduction. It has to fall between 0 and 1. So in this case, 3/5, K is 3/5. That scale factor, because this is less than 1 and greater than 0, we would call this a reduction. And that would be our explanation to explain it is because our K value is between 0 and 1. Let's now look at number 13. We're going to find the indicated side length. It wants us to find VM. So here is our side length V to M. When we work with these, if a parallel line is cut through the triangle, if a line is cut through the triangle and it's parallel to a side of the triangle, then the sides of this triangle are proportional. So we can set up X2. We would need to know this piece here. So in order to find that, we know the whole entire length is 42. This portion is 14, so that number would be 42 minus 14. So we can calculate 42 minus 14. That would give us the piece that we're missing, the 28. So we can set up our proportion. X corresponds to the 28. If you started on this side with the X, you must return to that side. So we need to get the 8, and it corresponds to 14. This is not the only way that this equation could be set up in order to solve. As long as you keep your corresponding pieces together. So you could have said X to 8, and then 28 to 14. Your corresponding pieces in your ratio have to match up with your picture. What you could never have done is X goes with the 14, because those are not corresponding in any way. Keep it consistent, either on the same side of the triangle or the same parts of the triangle, like a top or a bottom. Let's solve. Cross multiply, so we get 14x, 28 times 8, gives us 224. And we will divide that by 14 on both sides to get our x. So that gives us, dividing by 14, we get x equals 16, when actually it was asking for VM, so VM equals 16. Of course, you could complete the entire review for Unit 8 if you know that you need more practice in preparation for Test 3.